Hi everyone, hope all of you guys are doing well. Let's go ahead and do the next session for our electrochemistry. Okay, okay. So, in the last session, we learned about a question where we can design electrochemical cell, finding out which one is the anode, which one is the cathode, and how to write the equations, how to balance it, and then how you would put it together to construct a electrochemical cell. Okay, so we can build from here, and let's talk about electrical potential and the voltaic cell. Okay, so when the switch of the electrochemical cell is closed and no reaction is occurring, each half cell is in equilibrium state. So the electron will start flowing if the switch is on. Okay, when it is closed, so we have two half reactions, each one is in equilibrium. So zinc solid becoming zinc 2 plus, removing 2 electrons, which is the oxidation, it is in equilibrium state. And similarly copper solid, copper 2 plus, in fact the other one would be copper 2 plus taking 2 electrons becoming copper. So this is equilibrium, so we can write it in either way. That is also in equilibrium, okay, for the copper metal and zinc metal. Now between the two, one is giving up electrons, one is taking up electrons. But how do we know which one is supposed to give out the electrons? That depend on their potential. Okay. Now let's see how to identify that. So the zinc, in this case between zinc and copper, zinc is a stronger reducing agent. Remember, reducing agent is the one that undergoing oxidation. So zinc is the reducing agent, meaning it helps copper to reduce by taking 2 electrons. Copper 2 plus take 2 electrons and become copper. So reducing agent is the one that would undergo oxidation. So that is the zinc. So zinc is a stronger reducing agent than copper. So the position of the zinc equilibrium lies further to the right. So since zinc is a stronger reducing agent, so in this reaction, equilibrium will favor the forward reaction, or we say equilibrium lies further to the right. Zinc has a higher electrical potential than copper. When the switch is closed, electron flow from zinc to copper to equalize the difference in electrical potential. So they are not all the electrodes that we use going to have the same electrode potential. They have differences. That is why there is electron flow taking place. So when the switch is closed, what's going to happen is to equalize the difference in electrical potential, electron flow from zinc to copper. Okay. The spontaneous reaction occurs as a result of the different abilities of these metals to give up their electrons. That is the reason why we see a spontaneous reaction. Since there are two different electrode potentials, one has a higher electrode potential compared to the other one. Okay. So cell potential. A voltaic cell converts the delta G. Delta G is the Gibbs free energy of a spontaneous redox reaction into the kinetic energy of electrons. So kinetic energy is the one that is responsible for movement. Remember, kinetics mean the movement of electrons, even the movement of us. Remember, when you guys are sitting down, you have potential energy, you stand up and you start moving, then you are using your kinetic energy. So similarly, the delta G that generate helps electrons to move. Basically, voltaic cell converts delta G of a spontaneous redox reaction into the kinetic energy of the electron. So the electrons start moving. The cell potential. The cell potential is given the symbol E cell of a voltaic cell depends on the difference in electrical potential between the two electrodes. Each electrode has a different potential. So the cell potential depend on the difference in electrical potential between the two electrodes. Cell potential is also called the voltage of the cell or the electromotive force. You may see voltage in some batteries that we use in day-to-day life. That is the cell potential, meaning the difference in the two electrode potentials, or we call it as the electromotive force, EMF. Now this E cell needed to be greater than 0 for a spontaneous process. Energy of the cell, E cell, need to be greater than 0 for a spontaneous process. So remember that. So these are voltages of some voltaic cells. Common alkaline flashlight battery 1.5, lead acid car batteries 2.1 voltage. If you have 6 cells, 12 volts. Calculator battery 1.3, lithium ion battery 3.7, electric eel 0.15, nerve of giant squid across cell membrane 0.07. So the voltages of some voltaic cells. Measuring the standard cell potential of a zinc copper cell. How do we measure it? So we can use a voltmeter. Okay. The standard cell potential is designated as E0 cell. Always when you have this little degree mark right there, that tells you that is a standard cell potential. Like the standard enthalpy, standard entropy, standard Gibbs free energy, like that. Always this little degree sign denote it's at the standard condition. So that means it measured at a specific temperature with no current flowing and all components in their standard states. Current is not flowing, they are at the standard state. So the standard states are normally 1 atm and 25 degrees Celsius. And if it is a solution, 1 molar. So here we have two half cells. So this is copper half cell, which we can easily identify because the copper normally makes blue solutions like copper nitrate. And this is the zinc. So the copper half cell is the reduction, which is the cathode, right here. And then this is the zinc half cell, which is the anode, where the oxidation takes place. And then when you measure the cell potential or the voltage, that is 1.10. That is basically the difference between the two electrodes. I'll show you how to calculate this. Okay, and see here it is E0 is 1.10. Remember, in order for a spontaneous reaction to take place, E0 cell has to be greater than 0. Okay, E cell greater than 0. So how do we calculate this standard electrode potential? The standard electrode potential E0 half cell, for each one is the potential of a given half reaction when all components are in their standard states. By convention, all standard electrode potentials refer to the half reaction written as a reduction. When we are given standard electrode potentials, you will see those half reactions are written as a reduction. So that is the convention. Okay. The standard cell potential depends on the difference between the abilities of the two electrodes to be reduced, that is, to act as oxidizing agents. So, excuse me, the standard cell potential depends on the difference between the abilities of the two electrodes to be reduced, that is, to act as oxidizing agents. So this is the equation that we need to use if you want to find out the E0 cell. E0 cathode, which is where the reduction takes place, minus the E0 anode, which is the oxidation. Remember, E0 cell equals E0 cathode minus E0 anode. Okay. Using E0 half cell values to find E0 cell. Balance the following skeleton ionic reaction and calculate E0 cell to decide whether the reaction is spontaneous. Remember, E naught cell need to be greater than 0 for a spontaneous reaction to take place. So we are given this reaction. Manganese ions becoming permanganate ion, bromine becoming bromide ion. Right? So how are we going to do it? We balance the skeleton reaction. Then we look up the E naught half cell values from the appendix and use the equation to find the E naught cell. E naught cell is the cathode minus anode. If E naught cell is positive, the reaction is spontaneous. So let's go ahead and balance and find out which one is the cathode, which one is the anode. In order to find the cathode and the anode, we can see which half reaction is oxidation, which half reaction is the reduction. Now let's balance this one, manganese ion becoming permanganate ion. Okay, so how do we balance it? So let's remind how to balance this. Manganese ion, remember I showed you earlier in a previous, okay, I can do it over here. There are some space. So let's go ahead and balance. Manganese ion, Mn2 plus becoming MnO4 minus in ionic medium. Remember I showed you how to balance. So first we have to look at the atoms other than oxygen and hydrogen. So there is one manganese, that's balanced. And there are 4 oxygens. How do we balance oxygen? You add the same number of water molecules. 4 water molecules. Now we added 4 water molecules. So how do we balance then? Hydrogen. There are 2 times 4, 8 hydrogens. So 8 hydrogens goes to this side, 8H plus. Right? And then we have to check how many electrons we need to add. So there are 2 plus here, plus 2. Water is neutral, so there is nothing coming from water. And MnO4 minus 1 from manganate ion plus 8H plus. Minus 1 plus 8 equals plus 7. So plus 2 goes to plus 7. What is it? Oxidation number increase or decrease? Oxidation number increase. If it increase, is it oxidation or reduction? If the number increases, it's a oxidation. Oxidation means loss of electrons. Oxidation is loss. So to go from plus 2 to plus 7, how many electrons does it need to be lost? Going from plus 2 to plus 7. If you lose 1 electron from plus 2, it would be plus 3. 2 would be plus 4. 3 would be plus 5. 4 would be... Okay, plus 7 is 5 electrons. So 6 would be 4 and plus 7 means you lose 5 electrons. So if it is a loss oxidation, you put your electrons onto this side, 5 electrons. So that's how you balance that equation. Let's go back and see if I did it right. Yes, I did. So manganese ions, 4 water, permanganate ions, 8H plus, 5 electron, which is our oxidation. And then let's see how to balance the other one, bromine going to bromide. Bromine, Br2 goes to Br minus. How do we balance this? There are 2 bromine here, so you have to put 2 right there. We don't have any other atoms. Now we need to balance oxidation numbers. Bromine charge is 0. 2 Br minus is there a negative 2. What happened to oxidation number? 0 goes to minus 2. Is the number increasing or decreasing? Number decreasing. If the oxidation number decreasing, that's a reduction. Reduction is gain. Oil rig, RIG, reduction is gain. So how many electrons need to be gained in order to go from 0 to minus 2? You need to gain 2 electrons. Right? So that is going to be the reduction half reaction. Okay. Now the next step is, now we figured out our two reactions, two half reactions, we need to add them up. So when we are adding it up, we want to make sure that our electrons are balanced. So there are 5 electrons in the oxidation, 2 electrons in the reduction. So what do we need to do? We need to multiply manganese equation by 2. So 2 times 5 is 10. So this need to be multiplied by 5. 5 times 2 is 10. So when you add it together, 2 manganese plus 2 Mn2 plus 2 times 4, 8 water plus, and then those are the reactants for the oxidation, and for the product 5Br2, giving you 2 times permanganate 2 MnO4 minus plus 2 times 8 16 H plus. That's it. And then 2 times 5 electrons 10, 5 times 10 electrons 10, that gets cancelled. Okay, so that is going to be the overall reaction. That is the balanced equation. Now the first one is the oxidation. This is your oxidation and this is going to be your reduction reaction. Now we need to find out what are their electrode potentials from the appendix. Okay, now tell me which one is the anode, which one is the cathode. Which one is the anode, which one is the cathode? Oxidation happens at anode or cathode? Anode. So this is anode. And reduction happens at the cathode. Right? So, and remember, E-node cell equals cathode, E-node cathode minus E-node anode. Now, the cathode potential is, you can find it from the appendix, cathode is, which is bromine becoming bromide, is 1.07 cathode production, cathode reduction potential, right? So 1.07 is the cathode. And then your anode is where the oxidation happened, which is manganese becoming permanganate, 1.51. 1.51 positive. So 1.07 minus 1.51 equals negative 0.44 volts. Now we got, for the E-node cell, we got a negative electron potential. If there is a spontaneous reaction going to take place, E-node cell needed to be greater than 0. So do you think this is spontaneous? No. The negative sign implies the cell reaction is not spontaneous. Okay, so that's how you would find, if you are given a reaction, whether the reaction is spontaneous or not. First you identify what are the two half reactions and then figure out which one is oxidation, which one is a reduction. Did I do 10 bromide? No, I did 5 bromide. You guys didn't even tell me. I did a little mistake. Did you see that? Over here, 5 times. I got this one correct. Oh, I forgot to put the bromide, in fact. Yeah, that's what it is. 5 times 2 plus 10 Br. I forgot to write that one. 5 times 2, 10 Br. Okay? All right. Okay. Okay, over here. So this is our overall reaction. Okay? Right. And then if E-node cell is positive, then the reaction is spontaneous. But we calculate, we find out our anode and the cathode. We put it into our equation. E-node cell equals E-node cathode minus E-node anode. Cathode, bromine becoming bromide, is 1.07. The other one, 1.51. Negative. We have to subtract. So it came to be negative 0.44. This reaction is not spontaneous. Okay. All right. Half cell potentials are measured relative to a standard reference half cell. Now you may be wondering, how do you know, how do you calculate these standard electrode potentials for individual electrodes? you normally do it against hydrogen electrode. Okay. Half cell potentials are measured relative to a standard reference half cell. The standard hydrogen electrode is the reference electrode and has a standard electrode potential defined as 0. E0 reference 0. This standard electrode consists of a platinum electrode. Remember, we need to have an inert electrode since hydrogen cannot have a solid substance, or you cannot make it like a solid. So we use either carbon or platinum electrode with hydrogen gas at 1 atm bubbling through it. Hydrogen gas is given as we bubble through it. The platinum electrode is immersed in 1 molar strong acid. So what is happening? 2H plus. I'm missing some stuff here. So 2H plus with a strong acid could be hydrochloric acid, aqueous 1 molar solution. Take 2 electrons and giving hydrogen gas. And hydrogen gas. And E node reference for this is 0.00 volt. Okay. H plus comes as hydrochloric acid. Could be a strong acid or sulfuric acid. HCl has H plus and it becoming hydrogen gas. So this needed to be 2H plus and this is taking electron because go from plus 2 to 0, which is reduction. So taking 2 electrons, hydrogen. So that's how you get this equation for the reduction. Determining unknown E0 half cell with the standard reference hydrogen electrode. This is how we find out unknown E0 half cell against hydrogen electrode. So you have 1 molar zinc. Now hydronium ion represent the hydrogen ion, H plus ions. Okay. Since hydrogen is set to 0 and then this guy over here, zinc, has a higher electrode potential. Let's say you even don't know that. You just put it together. And then you're going to immerse zinc electrode in zinc solution. And then you have a platinum electrode for the hydrogen. Hydrogen gas is bubbled through this. And then you put a salt bridge and then you put a voltmeter. And then you measure the electrode potential. So zinc in this case is going to be your anode because zinc is going to oxidize, and then the hydrogen is going to be your cathode. So the electron flow takes place from zinc to the hydrogen. We have strong acid H plus or hydronium ion take electrons coming from the zinc and become hydrogen gas. Okay, this is what happening in oxidation. Zinc solid becoming zinc ions and 2 electrons. In the reduction half reaction, hydronium ions take up 2 electrons and become hydrogen gas and 2 liquid water molecule. And this is the overall reaction. Zinc with the hydronium ion giving you zinc 2 plus hydrogen gas and water. And this is the pictorial diagram what's happening. Zinc becoming zinc 2 plus, give away electrons through the solid. It goes through the wire to the other side. Electron coming in through the platinum surface. And then we have hydronium ions and gain 2 electrons and become water molecules and hydrogen bubbles over here. Okay. Calculating unknown E0 half cell from E0 cell. Now in this one, the previous one, going back to that for a minute, you see here you use hydrogen electrode, standard electrode, and we made it to 0 reference. And then whatever the number that we read in the voltmeter gives us what is the standard electrode potential of the metal that we are looking at, zinc, in this case 0.76. If it is copper, it will also give us a number here. if it is aluminum, chromium. So you can dip the metal of interest that you want to find out the electrode potential, so you can measure it against the hydrogen. Sometimes it would be positive, sometimes it would be negative. Okay. Sample problem 21.4, problem and the plan. Calculating an unknown E0 half cell from E0 cell. Excuse me. A voltaic cell houses a reaction between aqueous bromine and zinc metal. You have bromine plus zinc given us becoming zinc 2 plus and 2 bromide ions. And for this one, for this whole cell, E0 cell is given as 1.83 volt. And we want to find out E0 for bromine, given that E0 zinc is negative 0.76 volt. Okay. So here it is given to us E0 cell is positive, meaning this is a spontaneous reaction, right? It is spontaneous as written. By dividing the reaction into half reactions, we see that bromine is reduced and zinc is oxidized. Thus, the zinc half cell contains the anode. We can use the equation for E0 cell to calculate E0 bromine. As it is given, since E0 cell is positive, we can see that zinc is becoming zinc 2 plus. Oxidation number increases, that's an oxidation. And then the bromine goes from Br2 to 2Br minus, so that should be the reduction. So zinc is the anode and then the bromine is the cathode. Remember our equation is E0 cell equals E0 cathode minus E0 anode. And this is the reduction. Bromine taking up 2 electrons becoming 2Br minus, which is the cathode. And then the zinc becoming zinc 2 plus and 2 electrons, oxidation, which is the anode. And we were given E0 zinc is negative 0.76 volt. So we were given E0 cell 1.83. What we want to find out is the cathode, which is for the bromine. E0 anode, so negative anode value is given as negative 0.76. You put that number here. Okay. So negative will make it positive, right? So 1.83 plus negative 0.76 equals E0 bromine. It's basic math, okay? So E0 bromine would be then 1.07 volts. That's how you find the unknown electrode potential if the E0 cell and then the other one is given, figuring out which one is the anode, which one is the cathode. Okay. Okay, we can stop this session here and move on with the next one.